All right, what's going on, everybody? It is Kistner again, and we are focusing on the last section of topic 1 in our books. It's section 1.7. On your student companion in your workbook, go ahead and turn to page 27. Page 27, and we're going to actually do this critique and explain together today. What we're going to do is kind of review, because this section is kind of a review based on what I taught you last time in class, which is kind of nice. We're going to be using the matrices function again on our calculators, and it says write a system of equation that represents each student's matrix. Now your book, if you haven't caught on, treats this like matrix A, and then they draw this little line called matrix B. They call that an augmented matrix. I always just use A and B because that's what we're going to use in our calculators. They are completely different, but it works the same way for us. So write a system of equations that represents each student's matrix. Well, if you remember, these are your X variables, and these are your Y variables, and these are your answers. Okay? So if we write this correctly, the first line becomes, for Alejandro, I'll keep that in blue because his writing's in blue, is 3x plus 4y equals 2.75, and 4x plus 4y equals 3. Okay, and then Iman has 3x plus 3y equals 2.25 from this line, 2.25, and then his is 3x plus 4y equals 2.75. Now to answer these next two questions, how are Alejandro's and Iman's matrices alike? How are they different? You can say a bunch of different things. For example, they have the same row, but they're in different positions. 3, 4, 2.75, and down here it's 3, 4, 2.75. But there's a lot of different ways you could say that. Same rows, different positions. I'm not too worried about this right now. I'm more concerned about you being able to write equations from matrices and matrices from equations. So go ahead and turn the page, and let's look at example 1 here. What is the solution of each system of linear equations? Now, you can try to do this. Let's just treat this as kind of like a review for us right now. I'm going to multiply this top equation by 2 to make my x's match. And I'm going to get 4x minus 5y equals, sorry, I didn't do that right, 4x minus 10y equals 22. Remember, I was very careless there, and you have to be very careful to make sure you multiply everything by 2. And then I have 4x plus 3y equals 9. And then I come through and I subtract, just like we did in class. Make a match and then subtract. The 4's cancel. Negative 10 minus positive 3 is going to be negative 13y. 22 minus 9 is 13. Divide by 13, y equals negative 1. Now plug that back into any of these equations. I'm going to plug it back into this one right here, the top one. So it'll be 2 times negative 1 minus 5y equals 11. So negative 2 minus 5y equals 11. Add 2, negative 5y equals 13. And I just realized I made a big time mistake. Sorry, it's very early in the morning here. I plugged it in for the wrong variable up here, didn't I? So I'm sorry, erase all of this, because y is negative 1. I want to plug it in for y into this equation. I get 2x minus 5 times negative 1. That's what you're supposed to do. Equals 11. And I apologize. 2x plus 5 equals 11. There we go. 2x equals 6. If you subtract the 5, x equals 3. So my ordered pair is 3, 1. Or x equals 3, y equals negative 1. Okay, now, so that's just the old way to do it. You can also do a 2 by 2 in a calculator. Let's look at that for a second. So in our calculators, go ahead and get that up. We're used to doing a 3 by 3 in here. But in order to do a 2 by 2, it's the same process. second matrix. I want to edit matrix A. We did this in class. Change it to a 2 by 2. It's a 2 equations with 2 variables. And it's going to change it there. And from here, remember, to show me work, all you have to do is write down what matrix A is. Probably should have done this first. And say it's going to go 3, negative 4. That's 3x, negative 4y, and negative 4, 8. And matrix B is going to be my results matrix, or my answer matrix, negative 18 and 32. Okay, so I'm just going to show you that you can do a 2 by 2 by hand. So you have 3, negative 4, I did that wrong, 3, enter, negative 4, enter, negative 4, enter, and 8. Okay, so there is our matrix A. Quit out, second mode, go back into the matrix menu, and edit matrix B to be a 2 by 1. It goes rows and then columns. Rows go side to side, columns go up and down, 2 by 1. And I want to change this to, let me slide this over, negative 18, 32. Negative 18 and 32. And we quit out, and we just simply go get matrix A, hit the inverse button, or x to the negative 1 button, go back and get matrix B, second matrix, get matrix B, and hit enter. And it's going to give us that my answers are negative 2 and 3. So remember, that means x equals negative 2, y equals 3. Don't leave it as the matrix. Leave it like this. So I just wanted to show you can do it 2 by 2, or you could have done this by hand. Either way, it works the same thing. It gets the same answer. You could graph both of these. They'll cross at negative 2, 3. You could substitute. You'll find your answers negative 2, 3. All right, let's look at our next example. It's another 3 by 3. Now, I want to talk about this because if you notice, not every single one of these is solved for a variable or solved for a constant, and not every single one of them has the same variables. So we actually have to rewrite this thing. This top one stays the same. This top function, or top line, stays the same because it's set up the way we like to see it. X plus y plus z equals 13. That's okay. This one is still okay as well. Y minus z. Okay, and I'm going to actually rewrite that for a second. I don't like the way I wrote that. Y minus z equals 3. Now I'm going to rewrite this to where all my variables are on one side. So I'm going to have 2x, negative 2x, sorry, because I subtract that 2x over, plus the z that was already there equals 0. Remember, if I subtract the 2x over, this becomes 0. And now I have a matrix that I can write down. Matrix A, and my pen is going crazy here. Let me erase that and make it to where it actually looks like an A. So matrix A here is going to be 1, 1, 1. The top line is 1, 1, 1. Now here's the problem. There is no x here, but I can't just say 1, 1. Remember, you have to have a placeholder for that x. In this column, this is like saying 0. I could actually do this. This is like having 0x plus y. So we have to have that placeholder. And that's the catch to this one. 0 goes here, and then 1, and then negative 1. Remember, it's x, y, z on each column. X, y, z on each column. And then this bottom row is going to go negative 2x. Then it's going to have a 0y, and then 1z. And that is matrix A. Matrix B is pretty straightforward if we set it up right. Okay. It's going to be 13, 3, and 0. And we're just going to go back through to our calculator and modify that. So second matrix, edit matrix A, edit matrix A. We want it to be a 3 by 3. And we're just going to change it to what we have on our screen right here. We have 1, 1, 1. We have 0, 1, negative 1. And we have negative 2, 0, 1. So remember, these zeros are here because those equations did not have that variable. Remember, it's your x column, your y column, and your z column. There was no x in the second equation. There was no y in the third equation. So quit out of here. Go back into your matrix menu. Matrix B. We want to edit matrix B. I almost screwed that up. And we're going to change that to a 3 by 1 again. 3 rows, 1 column. And we change our numbers to 1330. Quit. Now this is something I showed you in class, but I'm going to show it to you again just in case you didn't catch it. The last thing that I typed into my calculator was A inverse B. A to the negative 1B. So if I just hit the second key and then the enter key, it's going to give me that again, and now all I have to do is hit enter. I don't have to go through and type it again. And there are my answers, X, Y, and Z. So now I can just come back through to my smartboard here, my chalkboard, and actually type in X equals 2, Y equals 7, and Z equals 4, if I remember right. I was kind of drawing that off my memory there. Yeah, 2, 7, 4. That's my answer. You will also see it written as an ordered pair of 2, 7, 4. Because that is an ordered pair with a third dimension, with a third axis, with your z-axis. So either one of these works. Okay. So I just wanted to show you that example. I know it's a review of how to use your calculator, but I wanted to show you that example based on the fact that there's a 0 sitting here, like there's a 0y right there. Okay. Now, there's another. I just forgot. There's another phrase up here called "write the matrix in row-reduced echelon form to solve." Now, row-reduced echelon form looks like this. It's just something you need to just see. Row-reduced echelon form is when you have ones on the diagonals, and everything else is 0. So you can see the diagonals here. So this is like having x, y, and z, remember? So this is like saying x plus 0y plus z. That's the same thing as saying x equals, y equals, and z equals. That's the same thing because there is no other variables. X has the 1, and that's it. Remember, treat these as coefficients. So what your book is going to do to make it row-reduced echelon form, it's just like a new way to write it. It's the same exact thing. It's going to have that weird line here, and it's going to have what it equals. It's going to be 2, 7, and 4. So this is another way to write the answer. X equals 2. No x, y, no z, equals 7, no x, no y, z equals 4. That's just another way to write it. Okay, I'm going to leave part B to doing our notes tomorrow or whenever in class. Okay, and we'll talk about row-reduced echelon form again. What is the solution to the system of linear equations? Type that into your calculator and solve that. Both of these are going to be straight-up calculator problems. It doesn't say row-reduced echelon form. You can use your calculator again for this. Just change your matrix to 1, 1, 1, 2, negative 1, negative 1, 1, 2, negative 2, and your B matrix will be 55, negative 7, 10. That's a straight-up problem off of your work. Like I said, this section is basically a review of what I've already shown you. Okay, again, there's another example of it, right? Okay, so it's pretty simple if we just keep doing our calculators, and we'll practice this in class tomorrow. We'll do this word problem in class tomorrow as well. A student has $128 in a savings account. If she were to withdraw the money and was only given one $5 and $20 bills, sorry, how many bills of each denomination would she have? Assume there's 28 bills. She has 3 times as many $1 bills. So we're going to have to write our own equations and then write it into our own matrix. It's not that difficult once we start breaking down the words, I promise. But I will do that in front of you tomorrow. Other than that, make sure you understand what I've talked about on this video. Go back, run it back a couple of times if you need to. And other than that, this is Kistner out.